Okay, for this last part, we're going to use this simulation that you see in order to answer questions 12, 13, 14. We're going to omit 15, so you can write a big omit across that one. Okay, so we're going to omit 15, and we'll answer 16. And I'm not even going to read them all word for word because I think the simulation will make it pretty obvious how to answer these questions. Okay, so here we go. This is a simulation basically from 05, the month, 5th month, that's May of 2007. And here we go. So as we play the animation, you'll see that we've got clouds sort of marching along the equator in a east to west fashion. You have another band of clouds down here marching from west to east, and another one up here, west to east. Okay. So on number 12, this animation shows Earth's cloud circulation during a full month, which was May of 2007. The bright, blotchy clouds in the equatorial region can be seen flowing generally from east to west. Okay, so that's number 12. Should you highlight and answer that one? Number 13. It says this band of bright clouds in the equatorial region is an indication of what? Rising or sinking air. Remember, we said that generally speaking, we need rising air to form clouds, and generally speaking, when we have sinking air, we're going to have clear skies. So, in the equatorial region, because we have persistent cloud formation along the equator, that's going to be an area of rising air. So that's number 13. Okay. It says this band generally marks the locations where surface winds in the northern and southern hemispheres blowing towards the equator meet, and this is called the Intertropical Convergence Zone, ITCZ. And this band of cloudiness is characterized by the bright clouds that you see, indicating intense thunderstorm activity and by high rainfall rates. Okay? And it is roughly parallel to the equator around the globe. All right, number 14. The animation shows that to the north and south of the ITCZ, the Intertropical Convergence Zone, this zone right here, are broad expanses of relatively clear skies. For example, the Sahara Desert of northern Africa and the Kalahari Desert of southern Africa. So they're saying here is the Intertropical Convergence Zone. Okay, but then if you look to the north, you get this area in here where you almost never have clouds. And you get another area similar to that down here where you almost never have much in the way of clouds. So similar extensive clear sky areas are found around the globe at about the same northern and southern latitudes. The general absence of clouds implies that at these latitudes, the atmosphere exhibits persistent, and is it going to be rising or sinking air motion? Remember that generally rising air promotes clouds, sinking air is usually associated with clear skies. So the general absence of clouds here at these latitudes, here and here, implies that at these latitudes the atmosphere exhibits persistent sinking air motion. So we have sinking air for the most part at those latitudes. Okay, and play our animation one more time. Further examination, I'm now on 16. Further examination of the animation shows that in the middle latitudes, beyond the relatively clear areas in both the northern and southern hemispheres, are swirls of clouds marching generally from what to what? Okay, so they're saying here are the areas that we obviously have sinking air, and this is around 30 degrees north and around 30 degrees south. But up further to the north and further to the south, we have another persistent band of clouds. And which way are they going? They are marching generally from west to east. West to east in both cases. Okay? So, the swirls of clouds are marching generally from west to east. Those are the prevailing westerlies that we have looked at. Okay? And I think that's pretty much going to do it for Investigation 6A. I hope you guys learned a lot about global atmospheric circulation.